Calorimetry lab. The purpose of this lab was to use calorimetry to determine the specific heat capacity of an unknown metal in order to identify the metal. In other words, we were asked, what's this? Let's find out. But first, you're watching Chemistry with Natalie. Let's hop on the learning train. Here's an overview that represents the entire lab, or an abstract, if you will. In the lab, the mass of the water was determined and the initial and final temperatures of the water was determined. The specific heat capacity of water is in green because it is a known value, so it was not determined in the lab. You might have noticed that the temperatures of the metal are in purple. That's because they were indirectly measured through the temperature of the water that the metal was in. So that's just a kind of way to represent that. In the bottom equation, the values determined during the hands-on part of the lab are in green. The yellow value is the specific heat capacity of the metal, which is determined in later calculations. If you're confused about this equation in general, don't worry. I'll get to that later. Now for the intro/background theory. Firstly, specific heat capacity. Specific heat capacity is the amount of energy it takes to heat 1 gram of a substance by 1 degree Celsius. It is measured in joules per grams times degrees Celsius. As I was saying before, water's known specific heat capacity is 4.184 joules per grams times degrees Celsius. Specific heat capacity is an intensive property, so every substance has a specific heat capacity that allows you to identify it. Next is the first principle of thermodynamics. The energy of the universe is constant. This principle means that energy cannot be created or destroyed, which translates to the blue equation in the context of calorimetry in this lab. To elaborate on that more, in a calorimeter, there is no heat exchange with the calorimeter's surroundings. The only heat transfer is with its contents, the water and the metal. This basically means that the heat lost by the metal is equal to the heat gained by the water, which means that their sum is 0. Heat is equal to mass times specific heat capacity times the change in temperature of a substance. In variables, Q equals mc delta T. We can plug that into the blue equation from the slide before. Remember when I said, if you're confused about this equation in general, don't worry. I'll get to that later. There it is. mc delta T of the water plus mc delta T of the metal equals 0. If we move some things around, we get this. The production value of this video is about to plummet because I want to get this to you by tonight. Material. Note that I don't recall what was on the unknown metal, but you said in class that it was brass. The procedure is quite long, so please let me know if you want me to just leave it to This data table includes the masses of the water and the metal in addition to their initial and final temperatures and observations from each trial. This calculation table includes each trial's change in water temperature, change in metal temperature, and the determined specific heat capacity of the metal. The average specific heat capacity of the metal was the sum of the heat capacity of metal determined in each trial divided by 3. The determined specific heat capacity of the unknown metal is closest to the known specific heat capacity of brass, so the metal can be identified as brass. One key uncertainty in this lab was the heat lost when the metal was taken out of the boiling water, dried off, and transferred to the calorimeter. Although the recorded initial temperature of the metal was the temperature of the boiling water, the actual initial temperature was lower because some of the metal's thermal energy was transferred from the metal to the surroundings during the transfer to the calorimeter. The change in temperature of the metal was then too high, and the determined specific heat capacity of the metal was too low. This lab relied on the use of indirect measurements like calorimetry. The exchange of heat was not directly measured, but it could be determined by the temperature recorded with a thermometer and the mass recorded with a balance. Thank you for watching. Here are the works cited.